Hey guys, so at this point you've received your mole map and you probably are not really sure what to focus on. For right now, we're actually going to focus on this mass to mole conversion, and we're going to use that dimensional analysis that we started using way back in November. And we're going to focus on this conversion factor that's down here, the one that says A, molar mass, from the periodic table. So what I'm going to do is I'm going to show you how to use that information in order to calculate a few things and in order to do the work that you have been assigned for this week. We're going to separate it into two parts. The first video is all going to be on how to find that conversion factor, A, and the second part is going to be all on how to convert from mass to moles. Definitely make sure that you are ready to deal with an exit ticket on how to calculate your molar mass before the end of the week. Okay. So let's do a simple problem. Let's say that we were trying to find the molar mass of water. Water is easy. Different periodic tables are going to have slightly different numbers, but let's say we're trying to figure out water, and we know that the formula for water is H2O. Okay, you're going to have to pardon me because, well, I'm not really supposed to be using my neck as much as I am, so we're gonna have to make it work. Now, if you were to look on your periodic table, I already told you that these numbers on the periodic table were atomic mass units. It happens to also be the same as the mass of 1 mole of particles. Now, that doesn't matter a whole lot to you, except to know that if I wanted to measure out a certain very specific amount of, say, lithium, all I would need to do is to go on the balance and put 6.94 grams of lithium in, and I'd be able to easily calculate the number of atoms of lithium I have. But in the case of water, most of you have seen this formula before, a zillion times before, and so we're going to do an easy one, we're going to do a hard one. This will be the easy one. So you probably recognize that there are 2 H's in this formula and that there is 1 O. And I'm just going to remind you that I put a line underneath that O so that it doesn't look like a 10 when I go back at my notes. So if I look at the periodic table, the number underneath H is 1.008. So that's going to be times 1.008. And I'm going to get a number. And then the number under O is 16.00. You have to be careful about which periodic table you use because different periodic tables are going to give you different numbers, and so your answer will be slightly different. Try to use the periodic table that I passed out to you in class. That way we always wind up with the same numbers, and there isn't a whole lot of confusion as to why, a certain number looks a certain way. But anyway, so if I were to put this into my calculator, I would get 2.016 as the number for hydrogen. That's the mass contributed by hydrogen. And then 1 times 16 is 16. And I would add that together, and I would get 18.016. And if you look on the mole map that we had, do you see how it says blank grams of X is equal to moles of X? That's the place where I would put grams of water is equal to 1 mole of water. Oh, that's a little squished. I'll write that for you in just a second.